Hey, welcome to Passages in Applied Mechanics by Dr. Lorenz Garcia. Today, dynamics and mechanical drives. Mechanical drives are devices such as gearboxes and belts or chain drives, used for the purpose of mechanical power transmission. This power can be even channeled to power other equipment like pumps, blowers, air compressors, and other common industrial machinery. Unlike simple machines discussed in other lectures, whose action is usually intermittent, mechanical drives are designed for continuous operation involving rotating components. Some of the fundamental principles of simple machines, such as efficiency and velocity ratio, are also applicable to the study of mechanical drives, but, however, in the case of mechanical drives, instead of work done it is usually more convenient to refer to the power transmitted, in other words, to the time rate doing work, as will be seen briefly. Mechanical power and drive efficiency. All mechanical drives have an input side and an output side, usually involving a rotating shaft, sprocket or a pulley on each side. The torque exerted on the drive on the input, or driver, side is called the input torque, T in. The torque transmitted by the drive to its output side is called the output torque, T out. Mechanical power associated with continuous rotation of a component is given by, where, P, is power in watts, T, is torque in Newton meters. Omega, is rotational speed in radians per second, and finally, N, is speed in RPM. If the input and output power are calculated using the corresponding values of torque and speed, drive efficiency can be defined as the ratio of output power, P, out, to input power, P, in. Gear drives. Gear wheels operate in pairs to transmit torque and motion from one shaft to another by means of specially shaped projections or teeth. The teeth on one gear mesh with corresponding teeth on the second gear so that motion is transferred from one to the other without any slip taking place. There are four main types of gears: spur, helical, worm and bevel. Gear types are determined by the relative positions of the input and output shafts. The most common type is the spur gear, which has tooth elements that are straight and parallel to its axis. A spur gear pair can be used to connect parallel shafts only. Parallel shafts, however, can also be connected by gears of another type. Helical gears, for example, have a higher load carrying capacity than spur gears when considering parallel shafts. Bevel gears are commonly used for transmitting rotary motion and torque around corners. The connected shafts, whose axes would intersect if extended, are usually, but not necessary, at right angles to each other. The bevel gear has many diverse applications such as locomotives, marine applications, automobiles, printing presses, cooling towers, power plants, steel plants, railway track inspection machines, etc. Worm gear is a gear of high reduction ratio, connecting shafts whose axes are at right angles but do not intersect. It consists of a screw-like component carrying a helical thread of special form, the worm, meshing in sliding contact with a concave face gear wheel. Because of their similarity, the operation and efficiency of a worm and gear depend on the same factors as the operation and efficiency of a screw. The velocity ratio of a gear drive is equal to the ratio of the revolutions of the driver wheel, the input, to the revolutions of the driven wheel, the output, in the same time. In any interval of time, the same number of teeth from both gears come in contact with each other. Therefore, it can be seen that the velocity ratio is the ratio of the number of teeth in the driven wheel to the number of teeth in the driver wheel. Chain drives. A chain drive consists of endless chain of links meshing with the driving and driving sprockets as it is seen in a bicycle drive. The chain fits into specially shaped teeth cut in the sprockets, which prevent the chain from slipping. The tension force, F, T, in the tight side of the chain is responsible for the transmission of power between the two sprockets. In this case, the velocity ratio is inversely proportional to the number of teeth in the sprockets. The torque on each sprocket is equal to the force in the chain multiplied by the radius of the sprocket. In many respects the operation of chain drive is similar to that of a pair of spur gears. with the exception that the center distance between two parallel shafts is limited only by the length of the chain. Efficiency of chain drives is usually high, and for our purposes can be assumed to be 100%. Chain drive was the main feature which differentiated the safety bicycle introduced in 1885, with its two equal-sized wheels, from the direct-drive penny-farthing or high-wheeler type of bicycle. The popularity of the chain-driven safety bicycle brought about the demise of the penny-farthing, and is still a basic feature of bicycle design today. Flat belt drives. Power transmission by belts is possible only with sufficient friction between the belt and its pulleys. In order to provide the necessary grip on the pulley, both sides of the belt must be in tension. In other words, there must be a tension force in both sides of the belt. As a result of applied torque and the friction between the belt and the pulley, there is a difference between the tight side tension, Ft, and the slack side tension, Fs. It can be shown that friction limits the ratio between these two belt tensions according to the equation, where E is equal to E, is a constant equal to 2.718, and is usually available as a function key on most calculators. Mu is the coefficient of friction between the belt and the pulley, and theta is the angle of contact in radians. At the same time, torque is equal to the algebraic sum of the moments of the two forces about the centerline of the pulley, where r is the radius. Flat belt drives are used where power has to be transmitted for large distances between pulleys. The efficiency of flat belt transmission or flat belt drives is approximately 99%. The flat belt drives are simple, less expensive, flexible, and durable, and it gives better performance at high speed, gives smooth operation, and require less repair and maintenance. However, it could slip and creep, and large power transmission is not possible. V-belt drives. V-belts have a trapezoidal cross-section, where maximum width is almost same with the thickness. The V-belt drive benefits from the wedging effect produced by the rubber belt in the specially shaped groove of the pulley. The wedging action of the belt tension increases the normal force on the belt and hence increases friction, which provides the grip. The flat belt drive equation given above can be modified by the inclusion of the sine of 1/2 of the wedge angle as shown, where the Greek letter beta is equal to 1/2 of the wedge angle. Flat belts are employed for transmitting power to a long center distance, even up to 15 meters. The V-belt drive is suitable for short center distance power transmission, below 1 meter. Let's apply these concepts to solve engineering problems. Dr. Lorenz Garcia here, thanks for watching. Ciao.